Okay, so last week we learned how to solve systems of equations, and all of the systems of equations that we solved had one thing in common, which is that there were only two of them. And when there were only two systems of equations, they only had a total of two variables. All the ones we did last week had x's and y's. The question that we're going to answer tonight is, how do you solve a system when there's more than two equations? So first things first, if you have more than two equations, you have to have more than two variables. So in other words, this problem has x, y, and z. If I only gave you two equations, it would not be possible to do this. You can't do it if there are three variables but only two equations. If there's three variables, there's got to be three equations like there are here. So what am I going to do? Well, what I notice is something going on with these first two right here. I'm going to look just at the first two equations. That one and this one. What do you notice about just those two equations?
There are no two z, it's just z by itself.
Right, just z by itself, one is positive and one is negative. Yeah. So if I were to add these two together, like I did last week with the addition method, what would happen to the z's?
Go away.
They'd go away. Let's do that. 3x plus x is 4x plus y. The z's are gone, and it equals negative 14. So by adding these two together, I've actually done something really good. I have gotten rid of one of the variables. I had three variables, x, y, z. Now I just have two, x and y. If I could get a second equation that also only had x and y in it, then I would have two equations with x and y, and I could solve that using one of the methods that we did last week. So, for example, what if I took this top equation and this bottom equation and combined them somehow? 3x minus y plus z equals negative 15, and 2x plus 3y minus 2z equals 0. I don't see anything real obvious I can eliminate here, but what I want to eliminate are the z's. I really want the z's gone so that whenever I add them, I just have x and y like I do over here. So what can I do to eliminate the z's? They're already negative and positive, so that's good. The problem is this one's a negative 2 and this one's a positive 1. I really need this one to be a positive 2. So yeah, let's just multiply everything by 2. That sounds good. So that's going to give me 6x minus 2y plus 2z equals negative 30. And I didn't change anything on the bottom. I'm going to leave that one alone. Now, if I add these using the addition method, I get 8x plus 1y. The z's are gone, and it equals negative 30. Okay, so let's take a look at the two equations that I have now. I've got this equation that only has x and y in it after doing some addition, and I have this equation that only has x and y in it after doing some addition. Let's put these two together. And it was a lot of work to get to these two, but now that I'm here, I know how to solve these because this is what we did all last week in class, is to solve a system of equations with two variables. They're already kind of set up for addition, so let's just go ahead and do them that way. They're already lined up. If I added them right now, nothing would go away, right? Nothing would eliminate. So what can I do to make something eliminate?
Make one subtract.
Sure. Which one do you want to do, top or bottom? Bottom. Multiply the bottom by negative 1. So the top's going to stay put. And the bottom will be negative 8x minus y equals 30. Now if I add these, the y's are gone. Negative 4x equals positive 16. And then divide both sides by negative 4. And x equals negative 4. Hey, I am now 1/3 of the way finished. I got x. I got to go back and get y and z. And what I'm going to do is find an equation where I can plug in x and solve for y. Well, the good news is I got 2 of them. I got 2 equations right here that only have an x and a y in them. I think I'm going to go ahead and use this one. So 4x plus y equals negative 14. And I'm going to replace the x with negative 4. So 4 times negative 4 plus y equals negative 14. And now I'm off to the races. 4 times negative 4, negative 16. And then add 16 to both sides. Y equals 2. Man, that one was much easier. Now I'm 2/3 of the way done. What's the letter that I'm missing now? Yeah, I need to find out what the value of variable z is. Okay, so I need an equation that has x, y, and z in it. I got 3 to pick from. My 3 originals all had x, y, z. Since I'm trying to find z, I kind of like the idea of using the top one because that's the one with a positive z. So I think that's the one I'm going to use. Not really for any good reason other than it has positive z. Okay, so there it is. I'm going to replace the x with negative 4 and the y with positive 2. So 3 times x minus y plus z equals negative 15. Okay, 3 times negative 4 is negative 12, and negative 12 minus 2 is negative 14. And then if I add 15 or add 14 to both sides, z is negative 1. So, previously, whenever we got the final answer to the question, we would write it as x comma y. Here we've got 3 letters, so the answers are 3 variables. So the answer is going to be x comma y comma z. Negative 4, positive 2, negative 1. Now that is a hefty problem. That is a big kid problem. 1 whole sheet of paper for that problem, and I got some upsetting news. All of these are going to take at least 1 sheet of paper. You got big handwriting. It's going to be a long night for you. The rainforest is in trouble. Say it again. Negative 4, positive 2, and negative 1.
I'm kind of confused how you got a negative 1 if you have a negative 14.
I added 14 to both sides.
Okay, so
Negative 15 plus 14 is negative 1.
that's
Hey, let's do another one. So your goal with 3 variables is step number 1, eliminate one of the 3 variables. Once you eliminate one of the 3 variables, you can solve it the same that we did last week. So the hard part is getting one of the 3 variables. You saw in that problem, once we knew what x was, everything else was pretty simple. So our option is a little more open at the beginning of the problem. When you first start the problem, the question that you're asking yourself is, do I have two equations where something's going to eliminate in a very easy way? Do you see two equations where if I added them, something would go away?
The second and third.
Yeah, what about the bottom two? These guys right here. So let's do these. Negative x minus 3y plus z equals 11. X minus 2y plus 4z equals 0. And that is a really good choice because when I add those two together, what goes away?
Z. No.
The x's. Okay, so let's do that. So it'll be negative 5y plus 5z equals 11. Cool. Well, that's fine. That's a good starting place. I've got one equation where I have eliminated y and z, and I did that by combining the last two. So I need to take another pair of equations. It can't be the bottom two because I just did those. It can be the first and the third, or it can be the first and the second. Doesn't matter. One of those where I can combine them and eliminate the x's just like I did before. I want to end up with two equations that both have y and z in them. Now, it doesn't matter if you do 1 and 2 or 1 and 3, but it does look like 1 and 2 are going to be a little easier. Why does it look like 1 and 2 are going to be a little easier? Yeah, one's positive and one's negative. That's exactly right. So let's take those two. If you had did 1 and 3, if you had did, I English good. If you had done 1 and 3, you would still get the correct answer. So if you did not see just now, oh hey, that would 1 and 2 would be the easy ones, and you did 1 and 3 instead, you'd still come out with the same thing. This one's a little easier, like very, very little bit easier, because if I'd used 1 and 3, I would just have to turn that into a negative. It's not that big of a deal. Here I have a positive and a negative, so it is very slightly easier. So I want to eliminate the x's. What do I multiply by?
2?
2 on the top one's already 2, right?
Oh, sorry.
I want the bottom one. I want that x to be negative 2x. Okay, so that's going to give me, the top will stay put, 2x minus 4y plus 8z equals 2. And then the bottom, everything gets doubled. Minus 2x. So that'd be minus 6y. I don't know why I wrote a minus there in front of that 2. No idea. I was thinking something. I don't know what it was though. There we go. That's what it looks like after I multiply everything by 2. Which means the x's are now going to eliminate when I add them. If I add these up, x's are gone, and I get negative 10y plus 10z equals 24. Okay, so I have succeeded in my first goal, which is getting two equations that have y and z in them. Here's the first one, right there. And here's the second one right there. Those are the two equations I came up with that only have two variables in them. And this is what we did all last week, was solving a system of equations that has two variables. So those are going to be my two. Just going to stack them. And they're already kind of set up for the addition method because the y's, z's, equals, and constants are already lined up. So I think we're in pretty good shape for using the addition method. Who's got some ideas? Yes. If I multiply the top by 2, I don't know that anything would eliminate because this would be a 10y, a negative 10y, and a negative 10y.
Maybe instead of a negative and a negative next to the positive.
Yeah, so what do I need to multiply by?
Wouldn't that be negative?
Yeah, I need to multiply by negative 2. So let's multiply the top by negative 2. that's going to change all my negatives into positives. So 10y minus 10z equals negative 22. And the bottom stays put. I didn't change anything about the bottom. Okay, then what?
Work the problem.
Yeah, I think that's a good idea. Work the problem. Could you be a little more specific?
Wow, looks like your X and Y are completely done.
Well, the X's were already gone, right?
Y's and Z's.
The Y's and Z's are gone. Good. So negative 10 or positive 10 minus 10 is 0. Negative 10 plus 10 is also 0. So this whole side is 0. And over here, negative 22 plus 24 is 2.
But that's not X.
That's not true. 0 doesn't equal 2,
Nope.
which means...
It is undefined.
It's
Well,
not linear.
let's get the obvious stuff out of the way. 0 doesn't equal 2. This is false.
False.
If your statement is false, what does that tell you? I think I just heard you say it.
It's not solvable.
Not solvable or no solutions. Hey, that one turned out really well. I thought we were going to have to do way more work than that, but
Don't take a full page.
didn't take a full page. We call that a win. It's a win when it doesn't take a full page. So far, so good? The first step is definitely the hardest. If you can handle the first step, you're in good shape. And if you can't handle the first step, you're going to have a bad time. We'll do a couple more of these. Now I'm leaving a giant space in between, and you will see why in just a second. That is on purpose and not because I'm having a stroke or something. So now that you've seen how the problem is written, why did I leave that big space in there?
Don't line things up.
Right, I wanted to make sure the x, y's, equals, and constants were all lined up. So since the first equation did not have any z's in it, I just lined those up. So, what do you think?
We're trying to identify what is X.
Yeah, something we can eliminate. Nothing obvious, right?
No, because you don't have a positive 4z to eliminate z.
Yeah, nothing obvious. You're right about that.
Unless you,
So what if we just did, let's just pick two. Let's do like 1 and 3. Let's put those two together. Now, when I stack those two equations together and I'm looking for something to eliminate, there's only one option. There's only one thing I even could try to eliminate. What is it? Yeah, the y. How come the y is the thing I have to eliminate? Yeah, it's the only thing they both have. So how am I going to eliminate the y? This is 4y. I'd really like for this to be negative 4y.
sometimes it
Yeah, how about times it by negative 4?
yeah, times it.
That seems good. So the top's going to stay the same. 2x plus 4y, leave a little space, equals 1. and negative 4y plus 16z equals positive 12. Okay, so adding these two is going to eliminate the y's. Okay, so that's good. So 2x plus 16z equals 13. Cool. So I did the same thing that I did on the last few, just did it in kind of a weird way, which is that I eliminated one of the variables so that I was left with an equation that only had two. In this case, x and z. Right?
Yeah.
Okay, I got to do that again with any of the other two equations. It doesn't matter which two. Which two you like. This one has x and z, right? So I need another equation that has x and z in it. Turns out I already have one. Which equation already has only x and z in it? Yeah, the second one. So I don't even have to do any more work here. This one's good to go. And this one I just made. Let's put those guys together and see what happens. So here's number 2. I don't need to leave the space anymore because they're both going to have x's and z's. Here's the second one, 2x plus 16z equals 13. Man, that's handy. Okay. Now what? Nothing obvious.
Well, to eliminate the z, you need the top one to be the same as the bottom. Negative form, so I guess top one times it by 4.
Good. If I multiply the top one by 4, the z's will go away, won't they?
Yeah.
So that'd give me 16x minus 16z equals negative 4. And on the bottom, 2x plus 16z equals 13. I think we're good to go now, right? Let's just add them. So that gives me 18x equals 9. That's a good idea. Divide by 18. 9 over 18, don't write 2 for God's sake. 9 over 18 is a half. 1 over 2 or 0.5 if you're nasty. So I still need to figure out y and z. I think figuring out both of those is going to be pretty easy because I need an equation where I can plug in x and find y, or plug in x and find z. So I'm looking for an equation that has only an x and a y, or only an x and a z, and I got one of each. Let's do the top one first. So 2x plus 4y equals 1. Solving this equation is going to tell me what y is when I replace the x with a half. Okay, what's 2 times a half? 1, good. So 1 plus 4y equals 1.
Okay.
And then
Minus the 1 on both sides.
that is a good idea. So 1 minus 1 is 0. So I get 4y equals 0.
Yeah, you can't really do multiplication with 4, right?
I can't?
Sure you can. Go ahead and do it.
Do what?
Multiply 4.
I'm already multiplying by 4.
I mean,
Divide 4. I can do 0 divided by 4. It is 0. Cool. Okay. I'm liking this so far. No complaints. All right, I got x, I got y, I need z. I like the bottom equation. y minus 4z equals negative 3. I like that one the best for finding z because I substitute y, which is 0. Plugging in 0 is really easy. So I am a fan of this. So 0 minus 4z is negative 4z.
And divide by negative 4.
Good. Z equals, and then negative divided by negative is positive, so positive 3/4. Man, 2 fractions in this answer. What is happening? So the way you write the answer is just like the way you wrote the answer with all the rest of them, except we just add the z on the end. So it's x, comma, y, comma, z. And there's the answer.
Is this graphable?
That is such a good question. Is it graphable? And the answer is yeah. You can graph this, but not on a standard sheet of graph paper because a flat piece of graph paper only goes in the x and y direction. Z goes in and out. So x is left and right, y is up and down, z is forwards and backwards. So you have to have a special kind of graph paper to graph it. And I'm fresh out, so I'm sorry, we won't be able to do that. I know. Maybe I'll bring some next week just for fun. We can do it. I'm all out there. You could, I mean, you could print it. It's not like you have to have special 3-dimensional paper. Like it's just a regular piece of paper, but it's got a 3rd grid drawn on it. Some of the graphs look pretty cool. It's probably worth Googling what they look like. It might not be worth actually making one yourself, but it seems like the sort of thing somebody on the internet has probably done some interesting stuff with. Anytime you think to yourself, that sounds insanely complicated, somebody on the internet has done it. When you think, who would spend the time to do that? Somebody on the internet did, I guarantee you.
Well, they did it before then, too.
Yeah, but nobody knew about it, so does it really count?
Yeah. So I call it a book.
If I can't get all those sweet likes and retweets, did it really happen?
Chopping a tree, of course.
If you cut a tree down in the forest and it lands on a mime, does the mime make a sound? Glad we're here to ask the important questions. So, this is kind of a weird one. I want to show you a little trick to solving this problem. And actually, you're really going to like the first step to solving this one. The first step is I'm going to get rid of the fractions in the 3rd problem. So how could I get rid of the fractions there?
So if you times by a common denominator?
Which is?
I'll say 2.
Yeah, let's multiply everything in the bottom by 2. So I'm going to take just this equation right here. And I'm going to multiply every part of this equation by 2. Now the reason I'm doing this is just to get rid of the fractions. So 1/2 times 2 is 1. 5/2 times 2 is 5. Z times 2 is 2z, or not 2z. And then I get x minus 5y minus 2z equals 6. And here's where I start to get a little suspicious about this problem. Get a little suspicious about it. Because what do you notice about this new equation that we wrote after we got rid of the fractions?
Looks a lot like that first one.
It looks identical to the first one. These two equations are the same. And that makes me get suspicious about equation number 2. Is equation number 2 also the same? So let's look just at that one. This would be negative 2x plus 10y plus 4z equals negative 12. Is there something I could do to make that one look the same?
Yeah.
Now notice this x had a coefficient of 1. This x had a coefficient of 1. What could I do to make this x have a coefficient of 1?
2.
Let's divide everything by
Divide by 2.
2?
Yeah, 2. Yeah, divide by 2. Or negative 2.
I like negative 2.
Negative 2.
Because I want to get rid of the negative also. So that's going to give me positive x minus 5y minus 2z equals 6. Oh my goodness. Equation number 1, equation number 2, equation number 3. What do you notice? They're all the same. Now, I know that, much to your disappointment, I have not shown you how to graph things that had x, y, z. But let's just suppose, for the sake of argument, I bust out our super cool graph paper and we graph all 3 of these lines. What would they look like? They'd be all overlapping one on top of the other. Now, the point of a system of equations is, where's the spot where the lines intersect? In every point. So, what are the solutions?
Infinity.
There are infinite solutions. Now, if you really want to impress the ladies at the math party, you will occasionally see this written like this. The solution is the coordinates x, y, and z, such that, this is from our set notation we did a few weeks ago, x minus 5y minus 2z equals 6, which is the equation. You will see this written both ways. If the person writing the question is in a good mood, the answer will be infinite solutions. And if they're in a bad mood, it'll be x, y, and z such that this equation is true.
Let me ask you a question. Is this computer going to want it done that way?
Yes, both. Both.
Both.
You should be prepared to do it. Write both. You should be prepared to write both infinite solutions and also the set notation. Be prepared for both of those.
Give you the option to have an infinite solution and then...
No, it won't have the option. It'll say write the answer like this. And it'll either be write it as infinite solutions or write it as the equation. It won't say pick your favorite. Sorry, Roy. It's not going to be dealer's choice.
Sure. It's not like one or the other, right?
It's like your wife. She never says just do whatever you want to do. You always get very specific instructions. Same thing. Same thing. Let's do one more of these. Let's do one more of these systems of 3 equations. I'll give you one of the harder types. Now, when I say harder, I just mean it looks weirder. The process is the same every single time.
Let's see when we can eliminate the z.
Yeah, we can combine 1 and 3 together to eliminate the z. That's not the worst idea. We'd have a problem left with just x and y, and that's okay. That's similar to the third problem we did. Bring that back up. Third one we did that had the missing variables.
Mm-hmm.
We eliminated one of them, and they were like, oh, hey, this one has x and z left in it. We've already got one that has x and z left in it. Let's put those two. And this one was, I think, fairly easy in the grand scheme of things, right?
Mm-hmm.
I want to show you a little bit different way to do this one, though. A little bit different way to do this one. I'm going to show you a little trick. We'll see if you like it or not. Take a look at this one. Oh, calm down. Good Lord, trying to blow out the devil over there? You scared the crap out of me. I'm going to take equation number 2, and I'm going to solve it for x. I'm going to add 3y to both sides. We get x equals 3y. Okay? It's going to become clear in just a second why I'm doing all of this. I'm going to take equation number 3 now. And I'm going to solve this one for z. Okay. Give me a second there to catch up. So I took the second equation and I solved it for x, and I took the third equation and I solved it for z. Why would I do that? That seems so very weird. Why don't I just do it the way we've been doing it all night? I mean, I just told you it'll work. Why don't we just do it that way? Imagine what would happen in the first equation if I replace the x's with this and replace the z's with this. What variables would be left in the first equation? If the z's turned into negative 55 plus y and the x's turned into 3y, what would the first equation look like? What variables would be left? Only y. Instead of x, I'm going to put 3y. This is the first equation here. Instead of x, I'm going to put 3y. Minus 4y minus 5, and instead of 5z, it'll be 5 times negative 55 plus y equals 35. What the heck is happening? Why did I do that? Okay, yeah. I can do a lot of things. I can eat a live scorpion. It's not recommended. What did I gain by doing that? Other than a big headache. How is that good?
Well, you can add all your y's together.
Yeah, I only have one variable left in this equation. This is all y's. Now there's a bunch of algebra to do, but who cares? It's all y's. 3y minus 4y, and then I'm going to have to distribute this. So 3y minus 4y is negative 1y. What's minus 5 times negative 55? Positive 275. Negative 5 times y minus 5y. Cool. Okay, let's combine the y's. Negative 6y plus 275 equals 35. I know this is a lot of algebra, but I only have y in here, so when I'm done, I'm going to actually know what one of my variables is. That's negative 240. Divide both sides by negative 6, and after a long, long, long amount of algebra, y equals 40. Whew. That's not bad. I mean, we've done worse things. Now, if I lost you here in this process, I want you to know that this problem doesn't have to be done this way, right? I could have done it the old way. This is just a little faster if you see it. If you see like, oh, hey, some substitution will clear this up. This is faster because now that I know what y is, I got to find x and z. That's really easy because this equation only has x and y in it. So let's replace the x with 40. I'm going to come down over here and do, this is equation number 2. X minus 3y equals 0. I'm going to replace the y with 40. So x minus 3 times 40 equals 0. So x minus 120 equals 0. Add 120 to both sides. And x equals 120. And now I need to know what y is. X minus 3y equals 0. Let's come down here and do it. X minus 3y equals 0. And I'm going to replace the y with 40. Oh, sorry, I don't want to do that one. That's the one I just did. Derp. Negative y plus z equals negative 55. Let's replace the y with 40. So negative 40 plus z equals negative 55. Add 40 to both sides. Z equals negative 15. Oh.
I can't see the bottom.
Oh. I know these problems are so long it's hard to fit them all. So my answer is 120, 40, negative 15. Again, we could have done this the old way. We didn't have to do it this way. But if you see this way, like, oh, if I just do a little bit of substitution, I can get one of the variables real fast. Once you know one of the values, everything else kind of falls into place pretty quickly. So if you can get one of them real fast, do that. Because the other two, like, it took us a while to get y. But once we had y, it took us maybe 30 seconds to get x and maybe 30 more seconds to get z. Once we knew one of them, we were home free. So your goal with these problems is there something I can do to get one of them real fast? And usually the answer is yeah, if it's one of these where you've got a missing variable like we had on these. Usually you can get one of them pretty fast. Does anybody have any questions about triple variable systems?